This is part 3 of the video lecture on Chapter 12, Water. So in part 2, we ended up talking a little bit, began talking about oceans. So oceans cover 71% of the Earth's surface, they contain 98% of the Earth's water, and the average salinity is 3.5%. That's really important for you to remember, because that salinity is what drives these ocean belts that regulate our climate and our temperatures with, our local weather and our climate. Okay, and these oceans circulate and disperse heat around the world. There are these major ocean currents, which is what we were just discussing, and they are the circulation of ocean water affects the climatic patterns. So there are both these surface water currents and then there are these deep ocean currents. So there's two different types. There's surface water ones and then there are these deep ocean currents. The surface water currents that are out there are driven by wind, the Earth's rotation, and the water temperature. So they're driven by the wind, the Earth's rotation, and the water temperature. So if water temperatures increase, then these surface water circulation patterns are going to change. Okay, so that deals with that. The deep ocean currents deal with salinity of the ocean. So if the salinity of the ocean changes, then those change as well. Those change. Okay? We call these surface ocean currents gyres. So these gyres, there's a bunch of them, they control that surface water temperature, that surface water current. Okay? And they reach 400 meters in depth. Remember, they are driven by the wind, the Earth's rotation, and the water temperature. Here you go. Here are the gyres. These are surface water currents. There's the North Atlantic gyre, the North Pacific gyre, the South Pacific gyre, the South Atlantic gyre, the Indian Ocean gyre. Then there are what we call these vertical currents. These are the deep ocean currents. These are what we call vertical currents. They are caused by differences in temperature and salinity. So here's the thing. Right now the salinity of the oceans is 3.5%. If the glaciers melt, all the glaciers melt, they add fresh water into the oceans. Fresh water doesn't have any salt in it. So if you add fresh water to salt water, you're going to change the salinity of the oceans. You're actually going to dilute the oceans. So the oceans are going to become have less salinity to them. Okay, and when that happens, they're going to change these vertical currents, and these vertical currents significantly affect the global climate. So the global climate is going to change. So global warming changes the global climate. These currents move really slow, and as you can see, there's a warm surface low and a cold surface low. These are deep ocean currents. Remember, they're deep. The surface ocean currents are gyres, and they are driven by wind, the Earth's rotation, and the temperature. The deep ocean currents, or the vertical currents, are driven by the temperature as well as salinity. So all of these things play a big role. Even though it's water, it plays a huge role in our climate. So what are the impacts of humans to oceans? They provide more than 5% of the world protein for us. One of the major issues is overharvesting of fish and seafood and other aquatic agriculture in the ocean. There's all sorts of things that we use. Mineral and resources. Don't forget, a lot of oil can be found under the ocean surfaces, and we extract that at high rates. The other thing is, of course, pollution. Plastic waste is the biggest thing right now on everyone's mind. The other thing is microplastics. So a lot of us are unaware of these microbeads. Microbeads are in most face washes. You know, all those face washes that you feel a little rub in them. A lot of times hand soaps, any of those hand soaps that have a little bit of an exfoliating task to them. And sometimes they're even in our clothes. We don't realize it. But these microbeads they're minute microscopic plastic beads. And what happens is as they get into the ocean, fish swallow them. And then we actually eat them, which is not good. They have been banned now worldwide. It's going to take a long time for them to come out of all of our cosmetic products, and this is a big problem in the world today. So make sure that you're aware of that. Look on the back of any product. Most of the time exfoliating creams have it in there, and so you need to be aware of it, and you need to stop using it. You know, of course, companies, just like any other policy, they're supposed to phase it out by a specific date, but of course companies are going to drag their feet on that because it's cheaper to put plastics in it than it is to crush up shells and use natural apricot shells or something like that in the products. Here's a good example of plastic waste. You know, each year tens of thousands of tons of trash and plastic products, you know, the huge garbage patch that's traveling throughout the world. Big problem, especially plastic waste degrades down, it degrades down to really small pieces of plastic, and then those small pieces of plastic, when they hit the sun, they glitter in the sun. The fish think it's food, they go after it, they eat it. In fact, I think there was just recently a dolphin that was found, you know, deceased, and they cut open its stomach and it had, like, I don't know, a ridiculous 200 plastic bags in its stomach. I mean, can you imagine? Plastic bag waste is a huge problem, and I think hopefully within our lifetime, plastic bag use will be phased out. A lot of states now are starting to ban plastic bag use, and we're going back to paper again. I know it's easier to carry stuff in plastic bags, but we don't need a plastic bag every time we go everywhere. And so here are different, this is, you know, oceans recovering. There's 1% of oceans recovering. There are overexploited, fully exploited. There's about 53% of the world's fish stocks that have been completely exploited. So this is a big deal. And this is why we need rules and regulations limiting how much we can catch, how much can be used at a time. So how can we conserve water? Well, you know, because one of the big things is how can we conserve surface water? Because a lot of areas are running out of water. A lot of states are running out of water, and then we have to reallocate water to them. We're building cities in places where we shouldn't be, and in terms of that, we need to conserve surface water. So now we're moving on from oceans to how can we conserve water. Crop irrigation is one way. 70% of our fresh water irrigates crop. So what we need to do is become more efficient in irrigating our crops. We need to water it not at the high of the date, you know, of the day. 3 o'clock in the afternoon is not a great time to irrigate because most of that gets evaporated before it even hits the crops. So there's a lot of that we need to do. And farms are really not efficient, so we need to have more efficient farming. We need to stop growing crops that require so much water. Almond is a hot product right now, and almonds and avocados require the most water to grow. And you know where we grow avocados and almonds? In the most driest places in the world. So we need to learn that almonds are not the cure for everything, and that when we buy almonds, we need to understand that when we buy them, or avocados, we need to realize how expensive they truly are, and we should not be externalizing the cost of those products. Yes, almonds are like $6.99 a pound, but guess what? They really should be like $30 a pound because they require so much water to grow. Another way that we can is by reuse irrigation. So gray water systems are a wonderful way that we can reuse water. And these are toilets or washing machines that capture the gray water, and then we reuse that to flush our toilets. Who needs clean water in our toilets? You're just going to use it to go to the bathroom in. Low flow toilets, low flow shower heads, all of these ways are ways. Having a rain barrel at your house where you can have water from your downspouts outside of your house go into a barrel, and then I use that to water my plants. So these are ways that we can conserve water. This is used like this here is irrigated with reclaimed water. Of course, do not drink the water if it's reclaimed water, but you're able to water plants with that. Desalination, of course, is another way that we can use the ocean waters to create fresh water. Again, I talked about this earlier in part 1 of the lecture. There are downsides to desalination. One of them is cost. The other thing is that there's a byproduct of taking all the salt water out. Where's all that salt going to go? And then what we do is we reintroduce it back into the oceans, and we have to be careful with that, because if we put too much salt back into the oceans in one spot, we're going to kill all of the aquatic life in that area. We could do this through different ways. So desalination can be through distillation, which is boiling off the fresh water. We condense it, we capture it, and then it's almost like tea, right? We boil the tea. At the bottom of the teapot will be the salt water. What's left, we capture the steam in big condensing tanks, sorry, I apologize. And then that water is then, that fresh water is then filtered and then pumped to your house. We can do it through reverse osmosis, where we push the water through a fine membrane. The salt stays on one side and the water ends up on the other side. But remember, it's very expensive. It can only be used in certain regions. You have to be close to the oceans. They're built on prime real estate. So there's a lot involved there. Here's a really good picture of a desalination plant. You see how big these desalination plants are? Can you imagine on oceanfront property how much money it would be to have a desalination plant there, besides the cost of the energy to heat the water or push the water through a membrane, and then that water has to get pumped to your house. So it does significantly raise the cost of water. So you can see here the water comes in from the oceans. It's then diverted into here. It runs through all of its different tanks here. The big thing is then remember that that salt is left over, and we have to do something with that salt that's left over. So the next couple slides talk about the policies in terms of water. So, you know, the United States is really interesting because there are two different types of water rights. There are what we call riparian water rights and appropriated water rights. So on the East Coast, landowners adjacent to water have rights to reasonable use. They don't own the water, but they have rights to it. In Western states, it's really interesting. So your rights to water, you buy property. And a lot of times people buy property because it has the rights to the water on it. So if you live upstream, you can buy access to the water that's next to you. And then, so for example, you buy the property, and if a river runs through it, you have rights to that water, because if you're at the top of the river system, you have rights to the water first, and everyone else after that has rights. And they do this use it or lose it. So sometimes people just waste water, because if they don't use the water that's coming through their property, the next person will get it, and they don't want the next person to get it. They want to use what's available to them. They don't want the next person to get the water. So sometimes people just spray water for no reason, just so that they can keep the water that's coming to their property. It's crazy. It's completely different. U.S. water quality. So these are the different acts that we've put into place, and a lot of these started because of pollution, major pollution. So the first time we tried to regulate water quality was in 1899, the Refuse Act. Then came the Oil Pollution Act of 1924. Then the Water Pollution Act of 1948. The Clean Water Act of 1972, and we've had a couple amendments to the Clean Water Act since then, but of course policies take a long time to change. We should be updating it a little bit more often than that. There are, of course, international water laws, and this is a big problem, because what happens is water laws are usually, the state water laws are to 12 nautical miles off your coast. After that, it's open oceans. So a lot of times people actually go outside the 12-mile radius, because there you're in the law of that state. They go outside there and they dump all their pollution. If you're in the military, you know what I'm talking about. The ships, they open up their hatches and dump all of their sewage into the ocean. You can dump trash, other things out in the ocean. Unless you're caught by an international agency doing it, and which is really hard to catch because the oceans are so big. So this is one of our biggest problems, is people polluting the oceans outside the 12 nautical miles off the coast. The 12 nautical miles off the coast are usually regulated by the Coast Guard or somebody like that. But as soon as they get outside 12 nautical miles, a lot of people open up those hatches and they just let all their pollution go into the ocean, which is a huge, huge issue. In 1969, the Chuahunga River caught fire for days, and this is what brought upon the Clean Water Act in 1972. We realized how much pollution was getting put into our river systems, that actually a river system caught on fire. It was that polluted. So, you know, you can see we've made huge strides in terms of water pollution lately, though. Okay. So this is my last slide for this session. I'm sorry I rushed towards the end, but I'm running out of my 15 minutes, okay? So this is part 3 of the water lecture.